All right, good morning, everybody, and welcome to the weekly Storage API Sync. We have a lot of information we're going to cover today, a lot of updates on the relayer to our infrastructure and to our backend Subspace client as it affects storage. And we're going to be talking about some next steps we have here as well. Okay, so let's start by going around the group and getting some updates. Leo, since we didn't get a chance to talk to you yesterday, I'll let you go first so you can update us on what you've been working on as it relates to the infrastructure or anything to do with Storage API.
I pushed the latest version of the infrastructure with the latest machines in Terraform. And I was checking the Nazar last changes on the Docker file, and I tested locally. I left a comment in there. I think that there was a missing parameter in the boot node configuration. I don't know if you check it.
I do not see the comment.
Yeah. It was a missing RPC course. Al?
Oh yeah,
Yeah.
Serge also found it.
Yeah, and adding that, everything works fine, and I tested the relayer Docker Compose and also worked fine. And yeah, after that, I started to work in these changes on the relayer front end because actually the method itself is called fits.metadata now, and before it was fits.fits. And I improved the way it queried the information from the batches, and I got this in the UE like showing now. And also was working in this feature to be able to dynamically set the RPC endpoint. So in the same way as Polkadot, you can just in the URL add RPC equals WSS and the RPC endpoint and just hit enter and it will load the RPC that you are requesting. And that's for not having a different app for every deployment we made. So like Nazar requested, I at least made that change in the URL. And today I wanted to close this, maybe having some help in this error that I was talking with Nazar before we start recording. It's an error regarding I think maybe I am making too many requests or mishandling the RPC queries. But sometimes the UI got stuck and I got some ideas to fix it. And after that, I think that I was going to get this initial version of the Subspace JS to make a put object in the backend. And yeah, I think that that's my update for now regarding all this work we are doing in the last days.
Okay, thanks for the update, Leo. I'd like to go through all of that in a lot more detail and look through sort of what PRs have been merged and where the status is on some of this as we go through these different topics. But that's a great initial update. Okay, Serge, do you want to go next?
Yeah, sure. So most of the time I was busy with Aries Dev environment. Today I have updated environment using new CPU machine that Leo set up earlier, and yeah, I was following Docker Compose instructions, and so far it works okay. And apart from that, I was working on some technical debt issues related to relayer and Pallet Feeds, mostly tests. And also I was exploring the opportunity to add Polkadot as a second primary chain. And as I mentioned, there might be like collisions with para IDs because they can be the same. Different parachains can have same para ID on Polkadot or Kusama. So yeah, we need to make a decision whether we should have separate instances with two different configurations for every primary chain or other workarounds. And also I've been working on dynamically getting Kusama parachains, and yeah, the problem there is about endpoints, because currently we rely mostly on finality endpoints because they have like HTTP most of the time, and but not all parachains are on finality, and most of them do not have public HTTP endpoints, which we use in Relayer at the moment. Yeah, I guess that's it.
Okay, sounds great. All right, Nazar.
Talking about since like last week, I've been primarily working on fixing different minor issues related to node startup and restarts and to Relayer. There are a lot of different glitches that were only uncovered when we actually started running it for any prolonged period of time. So those were fixed. I was also working on the substrate side a little bit to add ability to store simple objects instead of feeds. So we can use that in Subspace.js later. And also added RPC server to the farmer. So we can use the plot of the farmer, that is like complete plot right now, to query pieces and objects that will again be used in Subspace.js. And I was also writing some instructions based on instructions that Leo created on how we can change the way we deploy things to use Docker Compose. And that is, I think, a little bit easier now in terms of maintenance.
Okay, great. On my side, I have been working with Nazar just to make sure we've got the requirements correct for the retrievability side as it relates to the simple puts that he's got working now, and what kind of Git we're going to expose, and talking about Subspace.js quite a bit and how we want the initial version of that to look. So we'll talk about that more later. I've also been working pretty heavily with several of our partners and the business team regarding all the announcements that we're going to be making next week. But we have announcements that are coming out with on finality. We have announcements that are coming out with parity, and at least 3 or 4 of the main parachains have agreed to do joint announcements. We're still going to be announcing everything else. It's just some of them we'll be doing sort of co-marketing with. So there's going to be a lot of announcements over the next 2 weeks or so that are going to be starting pretty soon here regarding all this stuff, all the great work you guys have been doing on the Relayer. Okay. All right. So now what I'd like to do is kind of work from the back of the stack up to the front. So let's start at the infrastructure layer because this seems to be where we've had a lot of challenges recently. So maybe Leo, if you can just, I don't know what the best way to do this, but I don't even have like a clear picture in my head right now of what the different like instances that we have are, like what size they're at and what's running on them. So if you could just maybe give a quick overview of that. I don't know, maybe you could share your screen and show us like DigitalOcean or something like that so we can get an idea.
Yeah, it's not too much. It's just we have 3 environments with 3 virtual machines and 3 dedicated volumes for each environment. And apart of that, we have the old machine with also is his own volume, where that volume is actually the centralized volume where Nazar puts all the data like updated, right? Maybe I can share. In here, I have recently pushed the latest state of the resources. And in here, you can see that we just have declared in terms of the machines that we are right now using. We have this areas depth, where we have this droplet with a C8 size. That's mean a CPU dedicated with 8 virtual machines. Sorry, with 8 dedicated CPUs. And in the same way, we have defined the Aries test B for this environment to make the switch. That is actually a shared virtual machine with 4 virtual CPUs and 8 gigabytes. And finally, we have this Aries testnet that is the oldest machine. That is also a 4 virtual CPU and 8 gigabytes. And each one of these has a 400 volume storage attached to it. And obviously, each environment has his own custom RPC in Cloudflare related to this droplet IP. And yeah, I think that's all in terms of latest infrastructure changes. I had some problems when I was scaling the virtual machines, actually, because if you try to scale to this C8 size, if you have more storage assigned to the virtual machine itself than the next size, you cannot scale and you have to recreate the machine from zero. And that we have to be pending of that, actually. At the moment, to scale to a dedicated CPU, it must have at least the less storage in that current size, actually. So, for example, if my current machine has 18 gigabytes of disk and my scaled next requirement by default has 14, you cannot, because you cannot like make the storage less than you have right now. And some consideration like that, but apart of that, I think that this is the full regime that we have right now. And if we actually go to DigitalOcean, we should be able to see exactly the same environments. And in here, we can actually check it in a clear way. That we have this Aries test with this machine, the test B with this other machine, and this Aries step with this other machine. And also each machine with his own volume. Yeah, this is volumes. This is a pending delete, actually, that I made later. I need to validate something, but these are the 4 volumes we got right now. And yeah, that's it. That's
I have a question.
Whole resume. Yeah.
You mentioned before on another meeting that it is not possible to mount the same volume to multiple machines as read-write. Is it possible to do that read-only? Because latest relayer can actually work with read-only archives. So maybe these archives we can store once.
What I tried is to research if we were able to do this multi-attachment, and DigitalOcean doesn't allow that. I think that maybe for some business reasons it is not convenient for them. But I mounted this one, actually. That is the first volume with the original data, where you are updating the things. And I created another tiny machine with an NFS client, and I was able to mount it and read the data from the relayer. That was like 4 days ago. But at some point, I had this read-only error with the log
Right.
file.
That
but
what was
that's
fixed.
I think that I can try again, and if that works, that's probably will save us a lot of volumes, one volume for each
So with
environment.
NFS, you were connecting not to the volume but to the other machine. Is that correct?
Yeah,
Okay.
you are
That makes sense.
connecting. Yeah, everyone will be connected to this volume.
Yeah, I'm wondering how fast it will be through NFS. It might be kind of slow. We need to test it.
Yeah, maybe we can create an environment for that.
But that would be helpful, so we don't have to like copy those archives over all the time.
Yeah, I actually got. I remember that I had a mini documentation about the NFS host configuration and the clients, but it's pretty simple. It takes like 15 minutes, and yeah, I think that we should be retesting that. If you said that is now read only, it should work, because the only problem that I had, it was that.
Okay, thanks for giving us an overview of that, Leo. That's a lot more clear now. And thanks for all the hard work on that over the last week or so. So I have a bunch of comments. I just want to stuff I've been thinking about here that I just want to make sure you guys are aware of regarding this infrastructure. So the biggest thing to understand is kind of going back to what Nazar just mentioned about the NFS storage that we're using, or like the way, not even just NFS, but like just the way that our storage is configured. We're not using like dedicated storage on the nodes for a lot of the things the nodes are doing. We're using this like elastic block store, and in some cases that's okay, but in some cases that's going to be a problem. We don't need to change it right now. Please don't take any of this as tasks. We're just having a discussion here, okay, about in the future what we can do. But so, for instance, we have some volumes where we're archiving this history of the other parachains so that we can retrieve it and put it in whenever we reboot. We have other volumes where we are plotting and then farming based on that plot. And then we have other volumes where we are storing the actual state DB, the archival state DB of the substrate node. And each one of those actually kind of has different requirements for what kind of storage it should be using or what kind of storage it can use. And they're all kind of using the same or similar right now. And so, for example, the one that I'm the most concerned about right now is that the substrate state database, the archival database of the node, and the sort of the state trie, from what I understand, is not on the local machine. It's like through the EBS, and it's not clear, and I don't think it's on an NVMe drive. So, for example, with Ethereum, you cannot run the state database on Ethereum on a hard disk. You have to do it on an NVMe drive because it's so slow to read and to update the trie. And as our blockchain gets bigger and bigger and bigger, as we archive more and more stuff, we're going to have the same problem. We're probably already experiencing it right now. Maybe we're just not. It's not obvious to us that we're experiencing that. So we're going to need to move to the point where we have a larger larger solid state drive dedicated to the instance that we're running, and that's where the state DB lives. That's what the client has access to. And because of the way that DigitalOcean works, where it's not very configurable as to like exactly, like you can't just sort of adjust any individual lever on like storage or CPU. You only have like these pre-sized kind of options that you can get. That's going to be a challenge for us going forward to size this correctly, and it's going to be expensive. So I think that we're probably going to need to move towards some sort of more composable infrastructure, like using AWS directly, for example, in the future. Like being able to pick an instance, like an exact instance size, an exact volume size, what type of volume it is, make sure that they're as close together as possible. So I think that's going to be one challenge. The other challenge is the whole idea of putting, the archives of pre-downloading them and having them ready for the relayer during this like initial Genesis seeding upload process was that it would be fast. But now we sort of reintroduced the network. It's not clear how slow it is, but I imagine it is impacting performance. Maybe it's marginal. Maybe it's an order of magnitude. I don't know exactly yet, but it's something that it's an optimization that we can think about in the future, because we're going to repeat this process, you know, of archiving from Genesis many times over the next 6 to 8 months, I believe, and it's just going to get harder, you know, because we're going to have Polkadot, we're going to have Ethereum, we're probably going to have Bitcoin, we're going to have all these other networks that are on here, and we need to really figure out how to make this automated and how to make it occur in like less than 24 hours every time we need to spin up a new node. And so that's another thing that we need to think about. And then the plot itself. It's actually interesting that we're already dealing with this problem of how, like, what type of cloud infrastructure to set up plotting for, because we actually kind of designed our protocol so that we didn't want this to happen in the first place. We didn't want people farming in the cloud. We wanted them farming on their home computer, right? So it's kind of designed with the expectation that you're running it with a local disk. Now, it doesn't matter if it's an HDD or an SSD, like that doesn't matter, the type of disk. But it's not really clear like how this impacts performance if you're plotting like over a network, and then you're solving over a network. Maybe it's negligible. I don't know, especially on a data center, if they've got like InfiniBand or something like that connecting these volumes, maybe it's negligible. But it's really not the way that we haven't been writing the application like the node and the farmer and all that designed for this kind of a context. It's certainly not optimized for that. So it'll be interesting to see how this works out. So this is just some food for thought here about the infrastructure and the backend, and kind of as we move forward, we probably need to think about how we want to kind of sort of fine tune a lot of this stuff. And I don't think we're going to be able to do it in DigitalOcean, honestly. We're going to have to think about what provider should we use. Eventually, we're going to want to use multiple providers. We're not going to want to be stuck with DigitalOcean or AWS. We might want to use Google Cloud. We might want to use Azure or something else. And like what I've realized is that as we move forward, like in a year, for example, and we split Subspace Labs and Subspace Foundation, one of the core functions, I think, of Subspace Labs is going to be to provide some kind of an infrastructure layer, some sort of a hosting layer for the actual backend, in the same way that Consensus provides Infura for the Ethereum network. So that means that Subspace Labs will run dedicated nodes, especially once we have sharding. We're going to have, you know, thousands of shards. We're going to have executors on each shard. Subspace Labs will run like a subset of those executors, like some bootstrap executors. It's probably not going to run farmers. It will run RPC nodes. And other people are going to want to run nodes as well. And we will probably want to try to make that as easy as possible for them. So this infrastructure piece is actually going to be, like, I think we've sort of underestimated. Like, we've thought about, well, from an engineering point of view, we need to, like, you know, write the client, and we need to like work on the front end apps and all this stuff. And it's becoming really clear to me that this infrastructure component is like a huge undertaking, and it's something that we're going to really have to think about as we move forward. It's going to be like a major sort of initiative, and it's not going to go away. It's going to be something like, as we grow, it's just going to be a bigger and bigger problem. So we just need to start thinking now about how we're going to, like, what's our sort of roadmap for infrastructure over the next 3, 6, 9 months as we scale this up. Okay, any thoughts on that? Okay.
Will all this scaling, all these infrastructure updates or scaling should be made like before we have like this decoupled execution model implemented, or before that?
It'll be after. The decoupled execution is going to start with just a single node anyways. So we're not going to have sharding for a while, but it's in the roadmap, like maybe 6 months at the earliest before we have any kind of sharding, maybe later than that. I'm just trying to kind of paint the picture of like where this is going in the long term. Okay, so in addition to like partitioning out the storage to be more composable, I think another thing we're going to need to do going forward is, like, we have these sort of monolithic instances right now where we have like a relayer, we have an RPC node, we have a client, we have a farmer, eventually we're going to have an executor, kind of all running in one node. At least now they are isolated through Docker Compose. So I guess that's good. So is that, I guess is that kind of the equivalent really of separating them between different instances? Is there any advantage now to actually running them on separate instances other than just resource utilization? Nazar?
They run all in separate containers, and those containers don't necessarily have to be on the same machine. So technically, we can take like every single container and put it on the different machine. But yeah, it's just not resource efficient right now.
Okay. So it's not really a matter of robustness. Like if one process dies or one container dies, it's not going to affect the rest of the system.
It will. Okay, if it dies, no. If it consumes too much resources, it will, because we don't have like limits, any kind of limits on those containers. So one container can exhaust all of the memory or like eat all of the CPU. But it is configurable if you want to go that route. We're just going. We're starting simple and move towards something more complex later.
Yeah. No, and I don't want to do this right now. I'm just trying to think ahead. So yeah, I do think, especially like with what you mentioned, Serge, about we probably need to set up like 2 relayers, like one for Kusama and one for Polkadot. So now, like, probably each relayer should be a separate instance. You know, the Bootstrap node or the public RPC should be a separate instance. Probably the actual like Genesis client and Genesis farmer should be a separate instance going forward. And really, like, realistically, even once we have the testnet, we might want to run like 3 Bootstrap nodes, like one in Asia, one in Europe, one in North America. And then once we get to mainnet, we might want to run like 3 on each cloud services provider, so that if one cloud service provider kicks us off because we're blockchain and crypto, that it doesn't crash our, you know, the gateway into our network. So as we move forward, we got to think about like, well, how do we actually make this like more sort of distributed? Even though it's centralized infrastructure, we can still have it like be a little bit more distributed infrastructure than just all rely on one provider. And I believe that. Go ahead, Nazar.
I think eventually we will also want to not think in terms of instances, but in terms of applications. So something like Kubernetes will come handy, because we can define like, take these machines if you need them, and we can just say deploy this application to figure out what kind of instance it needs to pull from the pool of available machines on AWS, for instance. But all of that will require like a team of DevOps people who will like focus all the time to just dealing with that kind of infrastructure. It's not something someone can do part-time.
Absolutely. Yeah. I mean, I think eventually like labs will have an entire division dedicated to DevOps. It'll probably have like a 24-hour DevOps operations center. There'll be people like, you know, continuously on call, like monitoring the DevOps, monitoring the network, you know, making sure that we figure out if there's any issues or whatever. Yeah, I think that's going to be, that's definitely a huge undertaking. That's maybe where we'll be in a few years. But that's just kind of like the long-term picture we need to keep in mind as we're moving. But I think you're right. Kubernetes is a great way to scale this as we move forward. Okay, so that's one thing I think is these multiple relayers and multiple instances. So I do think that's probably the path forward on how to handle the Polkadot problem right now of the conflicting para IDs, especially because you know, very soon Polkadot's going to have a lot more parachains, and the number for Kusama is going up. So we could be, you know, in a month or two, we could be at like 50 parachains between these 2 instances, or on one instance really, or 50 source chains. So we probably want to, you know, try to split that load just in case one goes down, they don't both go down.
And also, it's a Node.js application. It doesn't. Am I?
No, sorry, it's just a delay on my end.
Also, we are running a Node.js application, this relayer. It doesn't really like to use more than 1 core. So if you split the load between several applications, it's also helpful in that regard.
That's a good point. Yeah, I guess we could think about it in that way, using like Docker Compose as a way to get like kind of multi-threading within Node, in a sense, or parallelism. Okay. So I think, okay, so the last thing I have about infrastructure is, so the dev instance right now has been upgraded to this 8-core dedicated, but the test instances are both 4-core shared. Have we noticed any difference in the performance of the dev instance? And is it worth upgrading all of the other instances? Because in my mind, it's almost like the test should definitely be more powerful than the dev. Because they're the ones that are going to be, we really want to work correctly. But I'm just curious, what do we think about that?
Initial numbers show that it seems to be faster.
Yeah, like at least twice faster, according to logs.
Okay. In that case, I think we want to just go ahead and upgrade across the board to this dedicated 8-core instance on all of the test environments, Leo. Okay, so that is like an immediate task that we're going to need to do. And how is that going to impact the existing test nets? Is that going to have to like reboot them from Genesis, or is it just like a soft restart?
The current public testnet, I think that we have to rebuild it because it got an old version, an old image version. It actually it was still using the feeds.feeds. It doesn't have the feeds.metadata, and I realized that it's not updated. I think that we have to probably reset that.
So our new testnet has -b suffix in it. I would probably suggest to create another like -a.
Yeah.
And
yeah.
once it's working, we just kill the old one.
Yeah, exactly. I was thinking exactly the same.
Okay. And if we restart, so if we upgrade -b from shared to dedicated, does that mean we're going to have to restart archiving as well, or will it just stop and then pick up where it left off?
It would have been, but the node restart is broken on that particular revision of the node. So it will probably not be able to restart. Even if we pull the new image, it probably will, but you will not be able to join the network very easily. You'll need to like pull the old one chain spec, the old chain spec in order to join. Probably not a big deal, but something to keep in mind.
Okay. And that's the one that we were thinking of doing the blue-green deployment switch on. So we probably need to get that up to the latest so that it is more robust before we do that. So it sounds like it's something we're going to need to do anyways.
Runs. I think we can switch to it. It runs. It doesn't seem to have any like performance issues, at least not big ones. So I think it can survive a few weeks if we don't really change much on it.
Okay. Okay, well then let's do this. Let's leave the -b as is. Let's set up a new -a, Leo, that's a dedicated 8-core, and then we'll get all the latest and greatest images on there for the relayer and for the substrate node. And we will just go ahead and start that one up as well in the background to start archiving. And that way we've got basically a backup we can switch to in case the new one crashes, or once they're both up to the head, we can just do this blue-green switch again and get up to the latest. Does that make sense?
Yeah, so we need to create a test A with the same scaled size, with same size as that. No, latest changes.
And then we just need to actually start the relayer, start a node from Genesis on that one as well.
By the way, I have a question. How much time does it take to start a new machine like that with Terraform?
With Terraform, like 15 minutes. Yeah,
15 or 50?
15.
Okay, so that's
Yeah.
not bad.
And after that, like the installation of Docker and everything takes like 1 hour, being the harder step, like the copy of the archive to the volume. That's take like 20 minutes, sometimes 15 minutes.
Okay.
Okay, cool. I think that's it on infrastructure. We can probably start talking about the relayer now, unless there's anything else you guys want to cover on the infrastructure side. Okay. All right, Serge, let's transition to you, and let's go through the relayer in a little bit more detail and what the current state is and what the next steps are, the back end.
So in terms of features, there was no significant updates. I can walk you through pull requests, but most of them were like either like low-hanging fruits, like fixing logs or tests.
Yeah, let's walk through those at a high level. We don't need to go through the code commits line by line, but we can just go through, if you want to share a screen and just kind of describe the pull requests from the high level, that would be great.
Sure. 1 second. All right, so and we also had one in Pallet Feeds. Okay, so let's start with Pallet Feeds. I have implemented a bunch of tests, and also, so in order to run tests, we need like a mocks module, and yeah, with construct runtime and all the configurations for the modules which are used with Pallet Feeds, in this case only for frame system. So, and here is the tests module. So basically we test if we can create a feed, and we check what is the feed ID, because every time we create the feed ID is updating, incrementing by 1. So we compare the original value, which is 0 by default, and after we create, we check if the value has incremented. And we also check the totals hash map and the relevant event, because every time we create a feed, we have an event feed created with a feed ID and account ID. And after that, we test puts. So for puts, we have multiple tests, and so this one tests a happy pass. We put some data. In this case, is just a random put object, and we also include metadata, which is also random put object, and we specify the feed ID, and we check the metadata hash map. We check totals, because every time we put object totals value in feed in hash map totals, we update, we increment the count, and we also add object size to the total size, and we also check the event. So in this case, in case if we put data successfully, data submitted event is emitted with relevant data. And here is another test for like an unhappy pass. In this case, we are testing. So if we are specifying the wrong feed ID that doesn't exist, we should not be able to put any data, and therefore there are no events as well. Any questions on this? Okay. Yeah, so in Relayer backend, first I created a testing environment. I have added a framework called TAP. I added TAP to dependencies. I created a test script, and I set up an example tests, just two tests to test it. These tests are for target module, and we test the method called sendBlock transaction. So basically we create a mock API for the so this is basically we mock a Polkadot API when we connect to target chain RPC, and in this case we mock API so it has like successful result on put, and we test what that in case of successful put, this method should return a hash, and we compare the hash value from our mock result to the actual value, which
Sorry to interrupt. We don't need to go through this level of detail. It's great. I mean, I just think in the interest of time, maybe we can just hit the features that we're testing more than having to go through line by line of the code.
Okay. Long story short, this is a PR just set up environment, added testing dependencies, added testing to the GitHub Actions here. So every time we push changes, we also run tests, and a few mocks for testing purposes, and these two tests and more tests are coming in the next PRs. Any questions on the setup? Okay. So another PR was about error handler, because previously we had some uncaught exceptions and unhandled rejections. So in order to avoid that, I have added this process on listeners. And if we have uncaught exception or unhandled rejection, we log them and we crash Relayer. Any questions on this one? Okay, another one was, so we used to have problems with the APIs when we were trying to get blocks from the like HTTP endpoints, and quite often they used to fail. So I have added a retries. So in case of get block by number, and in this PR we only update get block by number, but in the following were added for other requests as well, similar options. So we don't stop retrying, so we do it forever, and we specify the timeout. So minimum timeout is 1 second, maximum timeout is 1 hour. And every time the attempt is failed, we log the error. And basically, that's it. Any questions on this one? Okay, this is the one I mentioned for logger. So previously we had timestamps in logs, which is not very like readable. So now we write date in this format, and you can see in our logs. Yeah, we show it like this. Pretty straightforward. Any questions? Okay, the last two are more tests, and in this PR I have added few more tests for target module. We already had two, so I added we already had tests for send block transaction method, and I have added for send block patch transaction. Pretty similar. We test happy pass and we test unhappy pass. And another one is for our utility functions. Yeah, so I added some mocks for signed blocks we receive from the HTTP endpoints. So in this case, this one is the basic one. This one is with extrinsics, and this one contains digest logs. And yeah, we import our utility functions, a bunch of them, and we test. We pass some data, which seems like looks like event records, and we test if the expected result is what we initially specify here. And again, we test the happy pass if it returns like true, for example, for this method, or and unhappy pass right here. And yeah, we have a method that converts blocks, those JSON blocks, to the binary. And yeah, we basically do the same. We apply it to one of those JSON files, and we compare the results with what we expect. And yeah, I also renamed this method, like a better name for one of the utility functions. I guess that's it. Any questions?
Oh, that looks good. Great. And all those have been merged?
Yeah.
Wonderful. What is the process right now for the Docker builds for the relayer? Is that automated yet with GitHub Actions?
Not yet. I'm gonna tackle this next. So today I did it manually, and yeah, next step I will figure out how to automate it using GitHub Actions.
Okay. Yeah, I think that's going to save us a lot of time. Once we can do that, that's going to be really important. Okay. And do we have a registry that we're using right now, like on GitHub? Or is it on Docker Hub? Where would those get pushed to?
Currently, we're using Docker Hub.
Okay. Is that what we want to continue to do, Nazar? Do we want to try to switch over to GitHub Container Registry?
If you want to make automated builds, I think it will be easier to use GitHub. It's more integrated.
Okay. So in that case, is there anything we need to do? Serge, do you have the permissions to set that up? Is that something we need to go in and set up in our organization to do that?
I will check what is required, and I will let you know if I need any help.
Okay. All right. And then once we have that, we're going to need to update. Let's see. Well, we're doing everything manually on pulling the images, right? We don't have any of that in Terraform or any of our automation yet. So that would just be change the commands in the documentation of where the target is to pull from. Okay. Okay. All right. What are the other next steps you have lined up right now, Serge?
So let me share the screen. I will show you the board. So apart from technical debt, more tests and some documentation and lucid diagrams that we discussed before for Relayer backend, I was, as I mentioned, I was working on getting some parachains. So currently we depend on these HTTP endpoints, and we discussed it with Nazar briefly that it would be nice if Relayer could support WebSocket endpoints. And that would simplify these tasks because every parachain and most of our chains expose public WebSocket endpoints. So we might automate this process of onboarding new parachains if we use WebSocket endpoints. So I think it would be nice to work on our own like raw lightweight client for RPC. But yeah, this is something we can discuss.
If I remember, this is the one where we're not using Polkadot.js to connect over WebSocket, but we're like writing our own like low-level WebSocket connector.
Right. For source chains, we're still using Polkadot.js for target chain to connect with Subspace RPC. But for other chains, we avoid it because if we use Polkadot.js, we need to specify custom types.
Right.
I think it shouldn't be that big of a deal because by now all the parachains should be upgraded to version 14 and we shouldn't really require it. But it will be certainly more heavy like on the CPU usage because every time you have like a new block, it will try to parse it and construct objects and stuff which we really don't need.
I can check if they all have updated, but
I remember
don't
that
think
there was some kind of requirement that when they updated I believe it was like Polkadot base. They basically said that you have like one more patch revision for upgrade before you become incompatible. So I think they were forced to upgrade at some point, at least parachains.
Okay, yeah, then using Polkadot.js might be easier, but we can try.
So if I understand, we can use Polkadot.js for WebSockets, or we don't need WebSockets anymore based on version 14
We can use it
metadata.
for both. We can use it both for HTTP and WebSockets. It doesn't really care too much.
Okay,
But
so we
it's
don't
much
need to write
heavier.
our own custom WebSocket adapter anymore.
I don't think we need to write it either way. There should be like JSON RPC library that we can use that will handle like low-level connections and pings and stuff. And we can just issue queries, kind of like we do on the farmer side, for instance.
Yeah.
But it will definitely be more efficient because there is a lot of stuff that Polkadot.js API does we surely don't need.
Yeah, a lot of stuff bundled together.
And it's not disableable.
Right. And that's going to allow us to connect directly to a public RPC that some parachain is running versus having to go through on finality for everything.
That is an open question because I know for certain that some of the parachains do expose their own RPC endpoints as an alternative, but they are not archival nodes. So we'll probably have to do some kind of probing, like try to get the block 0 or like block 1. Block 0 will be always there, but block 1, like if it doesn't return a result, it's probably not archival node.
Okay. Well, I think this is there's two use cases here. One is like syncing from Genesis, and the other is like real-time syncing. So if we've already got the sync from Genesis handled, then we should be able to retrieve like the latest blocks or the last few blocks from the last 256 blocks or whatever from the from just a full node.
Yep.
Yeah. So and that's really the concern here. It's not so much about the backups that we need redundancy on. It's about the real time. Like if on finality goes down, we'd like to be able to speak to the parachain directly, if we can.
Yeah, ideally we can even build a system where we have several connections, so we can like pull blocks from different connections even concurrently. So in case something is slow or something goes down, we can have a fallback right away.
Yeah. Yeah. So So what do we think? Do we want to just try it with Polkadot.js now, or do we need to write a custom adapter? Is it going to be worth the effort to do that?
Do we have parachains which are not on finality? If there is like one or
Yes.
two, I would start with Polkadot.js app API, and later we can think about upgrading it.
Yeah, we have Picasso right now, and probably more will be.
Okay. So let's do that, Serge. Let's just start with Polkadot.js. We just need to distinguish, we just need to make sure that we have some way to distinguish between syncing old blocks, like in this archive mode, and the real-time blocks as we're getting the blocks from the Kusama relay chain, right? And then we're requesting the pair of blocks in response. That we just need to make sure that we're only using the WebSocket connection for that for now in like the live mode.
Okay. And in case we want to like process them from Genesis, what should we do? Like, should we reach out to them directly to ask for the endpoint we can download old blocks to archive?
Oh, for the new change, you mean? I think we're going to have to do what we've been doing with the other chains, where we run an archival node and ourselves and back it up in our own archives.
But those had like on finality endpoints. And in case of Picasso, for example.
I was running archival nodes myself. So
Okay.
for all chains except Basilisk, because it's like hopelessly broken right now, the image that they have in public. And they didn't reply on GitHub to suggest me how can I run it.
Okay, understood. Okay, then I focused on Polkadot.js for real-time blocks and
Okay, so that all. Oh, can you guys hear me? My screen just froze.
We can hear you.
Is it Serge that froze?
He did for a second, but now it's fine.
Okay. Oh, there we go. I think I've got some internet problems today. Okay, and yeah, and then so yeah, I think the priority is going to be Docker builds, dynamically getting the parachains using Polkadot.js, and then having a second instance or a second container, second process that we're going to run Polkadot off of. It's not a huge priority, but like maybe next week, it would be great if we could start syncing Polkadot as well. And I guess that's another thing we're going to need to do is we're going to need to run an archival node of Polkadot and add that to our archive volume as well.
Should Serge run archival node for Polkadot instead of myself?
That would be preferred if you think you can handle that, Serge.
I can try, but I'm not sure I have enough space.
Oh yeah.
Let me check.
I mean, you can always just go set up like a vanilla, DigitalOcean droplet and just run that to sync it from the cloud. You don't necessarily have to do it in your local machine.
But we'll have to
Yeah.
keep it online, or at least like shut down state for a long time.
Yeah, I can try.
And this again is another thing that we need to think about long term in the infrastructure is like, are we going to run our own archival nodes for all these chains, or as we scale, how's
that
this
will be
going to work?
$1,000 per month to run all of them.
If we use DigitalOcean, if we use AWS directly, we could probably do it a lot cheaper. Something to think about.
Yeah.
Okay. Regarding the technical debt tasks that you have, Serge, how much time do you think you'll need before you're going to feel a little more comfortable with the kind of the robustness of everything?
It's hard to say. I think you can improve without any, limit.
Well, sure. How long do you think it'll take you to get to where you're like 80% confident that it's good enough for now versus like nervous about that it's very, very fragile like you were before?
We're talking only about tests, not documentation, right?
Documentation is important too. We need to have some baseline documentation.
I think we have some
Well,
like very basic one.
Yeah, we have a basic one, but well, I think 1 week approximately. Like if we have few more tasks in parallel, I think 1 week should be enough.
Okay. One week from now?
Total.
Okay. How much, but you've been working on it this week already, right? A lot of this like
Right.
testing and yeah. Okay, so a few more days dedicated to technical debt should be okay.
Yeah, I guess so.
Yeah, I mean we just need to
it's
time
hard
box
to
it at some
decide.
point.
It's hard
I'm
to
just trying to
decide
get,
where we want to stop.
well, I know we could go on forever with removing technical debt and optimizing it, but we just need to spend, let's just say 2 more days, 1 more day on tests, 1 more day on documentation, if you, or in terms of like your hours, think about it in that term. And then we'll work on these new features and then getting, then it's going to be sort of continuously upgrading this or not upgrading, but extending it for new parachains as we move forward and getting Polkadot working and trying to automate that as much as possible.
Okay.
Okay, anything else on the relayer backend we need to discuss?
No, I think we're good.
Okay, great. All right, let's transition to the relayer front end now. Leo, if you can kind of share your screen and walk us through the latest updates, and then I have some feedback kind of on the UI and the functionality as well.
Can you hear me? Yeah. There
Yep.
it is. This is the latest branch that I pushed. Update feeds from state. Yeah.
We see your Docker screen right now, Leo.
There it is. I think that I can create this one to check the file changes. Yeah, well, in here I basically added a Wrangler extra git ignore. I updated also to the latest version, the Polkadot API. And I added this function to get the WebSocket RPC endpoint from the URL. If it's set it from the URL, it will load it. Otherwise, it will just communicate to the default endpoint that is set it in the environment itself. And I also had to update this parachain table as we were losing this subspace block hash. But I think that today we can get this running again because now I can get it from the last event. And remove this block count and this block size and maybe leave the interface the same way we had before, right? With just the block number and finally the subspace hash. That's the idea, I think.
Yeah, that was going to be a question. I'm not. Why did we lose that?
Because before we were knowing the block where we were getting the events as we were subscribed to it, but right now we are querying the state. But right now I am querying the state when I have an event and I know this event block, and I can actually get the feed. If this feed is in this block, I can add the block number or the block hash to the UI again. I don't know if this was understood. Yeah, so
that makes sense. Yeah, I remember that now. Okay, but
yeah.
you're saying you can fix that now. We can return that feature.
Yeah, actually in here you can see that before we were using this extrinsic method, and for each extrinsic we were getting the feed ID, and we got the data and we got all the information like the last block hash, the last block height, the block size, and the subspace hash. That is, it was actually the current signet block, right? The current block that was emitting these events. And right now it's different. Right now I don't have that from the signet block. I just have this feed object with the feed ID, the feed block number, and the feed block hash. But I can, in here actually, in the next files, in the relayer context, I edited this relayer context to get the last feeds every time. Every time I get a new block, I get the extrinsic for this block. And if it's a batch all extrinsic, I just check if it includes a batch completed event. And if a batch was completed, obviously the last feed was updated, and I just get in. I just query for them again.
Okay, be careful here because it's not only batches. Like if you have just one transaction, it will be sent without a batch. So you need to support both the regular transactions and batches.
Okay, maybe.
So
Yeah.
when from archive it will submit
It's
batches, but
good
if
to
you
know
like
that.
at the head, it will just send one by one.
That's why sometimes I got the feed data submitted event just in one record, and sometimes I got like 2,000, 5,000, right?
Yeah, probably.
Okay, let me know that because
It's basically more efficient to send multiple using a batch, but it's less efficient to send one with a batch, so we send it like a regular one.
and what else? I think that's everything because this is the batch completed, and I also created this feed object to get the type, and this is the function where I get the RPC endpoint from the URL if it's set it. And yeah, and actually I had to make this relayer context provider in a higher place in the app itself, actually in the layout. And yeah, and that was, I was able to make these changes. And actually in my front end, I don't know why I am not getting the feeds. I'm going to try again. But in the link that I sent you guys, it was working for you. I don't know why it's stuck in there. Yeah, and it doesn't
It's
load
actually
the.
doing a lot of requests, but after a little bit of time, it should render it.
Yeah,
It's not like right away, but a bit later it should. That's also something
yeah,
that can
it
be
worked
improved,
because
like
I
rendering
tested in a friend
consistently.
computer up there, and oh, I'm actually getting lagged. I'm going to close that screen. because probably too many requests problem. And yeah, I think that those are the updates for the relayer front end.
Okay, and one more time, what are the next steps you have planned for the front end?
To fix this subspace hash and add the support that Nazar recently mentioned to get one by one. And yeah,
Okay.
after that, I think that if I still not able to get these too many requests solved, I probably will need some help in there. Yeah, and yeah, but with that we can have this front end back running.
Okay, great. Yeah, let's make those a priority after we get this dev test test A instance working.
Okay.
Infrastructure going. Let's make it a priority to get these changes made here to the relay to the front end. Let me just share my screen quickly, and I want to show you. I just want to give a little bit of feedback on this as well.
Yeah.
Okay, so some of this is UI related. So this down, okay, I did not realize that was a link. This down here, this permanent archival storage service, the first half, let's move it up to the top, or maybe up here somewhere, wherever it looks nice, so that it's a little bit more clear when you come in what it actually is versus having to scroll down to the bottom to see it. Of course, we'll leave the copyright down here. Okay, so that should be a pretty simple fix. I'll just kind of leave it up to you where, like, what looks nice. Maybe it just goes off to the right here, or like centered or something like that. I think it belongs in the header somewhere. Okay. All right, the other thing, the chain count, I think this is the target, sorry, the child chain count, because I count 1, 2, 3, 4, 5, 6, 7, 8,
it doesn't
9,
count
10,
Kusama.
12, 13. Yeah, let's change it, because I think it's a little bit confusing that there's actually 13 chains, and then as we add polka dot, it should count all the source chains and all the child chains together in this count. Okay. The other thing is, depending on there seems to be some difference in the layout depending on the screen size. So like right now, all of these boxes are the same, but when I'm on my laptop, it truncates this, and like this box ends up like coming down like this, and this box comes down like this because it has these icons associated with it, whereas these are they're like different size, so it looks a little bit wonky, like on a smaller screen. So I think these icons here are kind of not that useful right now, because we don't have icons consistently, and then we're like using the same icon twice. So I think we'll just remove the icons, and that should hopefully make that problem go away.
Set part size. Okay.
Does that make sense?
Okay. Yep.
Cool. Okay. And then, so we talked about the subspace block hash. We definitely want to bring that back in. I noticed there's some issues with which one of these links you click. So I was actually given a demo to Nate and Derek from Moonbeam yesterday, and this issue popped up. So if you click on the hash link, at least yesterday, let's see how it performs today. So this should fail, but we'll see. Oh, it worked. Okay, it's working now. It fit. Yesterday when I clicked on the hash link, it failed, and I had to click on this link, and that would work. But let's see, maybe it's flip-flop today. I don't know. Maybe it was just a bad block, or maybe it was too early. No? Okay, so this is...
I haven't applied these changes to the another public app. Yeah, it's just I was just testing in the dev layer.
Okay.
So yeah, I think that there was a problem in there before, that it was
not
like showing the latest blocks, and I think that is fixed in this version.
Yeah, because I was using the test relayer when I demoed it to them, so maybe maybe okay, so that problem's basically been taken care of. And let me show you what I mean here with this. Maybe this will, if I just resize.
You can
Yeah,
just
see how that.
Yeah.
Sorry.
You can try to increase zoom on the page. It will show the same thing.
Yeah, you see, this is like what it looks like on my laptop when I open it up. These are like all different sizes and they look kind of weird. So we just need to try to keep these consistent. I think just erasing these will help that. And we could also reduce the length of this text. We could just say blocks archived instead of total blocks archived, or total blocks maybe, like just make it shorter as well.
Yeah, that
So
could
it doesn't overflow. The other thing actually that I meant to mention, okay, let's see if it's doing it here. Yeah, it does this weird, like this gets cut off here if you're on a small screen. So like on my laptop, it will do the same thing. It will kind of cut off. It looks about like that when I open it up. And you have to come all the way down here to scroll over, which is a little bit weird. So if there's a way that we can just make this like truncate some of these fields, you know, maybe this one I think is the one that's really eating up most of the real estate here. So we probably only need to display like the last, you know, 6 of the hex, or the first 6 and the last 6, but like we don't need to display so much of the hex output here.
Yeah, I can listen the Windows width and hide and show some columns maybe.
Well, we
And
still want to
actually
show all the
make it
columns.
sure the
We don't want to hide any columns. We just want to make the columns so that they have like a max width, which is always, you know, the max width of all the columns should never exceed whatever the width of this element or this whatever div block it is.
Yeah, I think that's the default behavior of the Bootstrap table. I have fixed it in other projects with some tweaks. Yeah, I think
Cool.
shouldn't be. Yeah.
Great. I think you get the idea. Okay. What else? There was something here about one of these. I'm forgetting what it is now. Oh, the ordering. Yes. I know this is a minor thing, but if we can change the ordering to kind of put them like, I mean, just use your judgment a little bit, but like Moon River is currently like the top, you know, for Kusama or for Polkadot, they're in the lead right now, or they're like neck and neck with Akala. We're actually going to feature them first in our announcements. So if we can move them a little bit closer, like, you know, next to Korora, above Korora. So it should somewhat reflect kind of like the ranking of them in the community right now. So that's the one that really stands out. It should probably be like Korora, Moon River, and then Shiden. Those are sort of the top 3. And then like, you know, Kala, the Frost, like some others like that. So roughly they should go by the batches where they were
Basically,
onboarded.
take the last block height and sort it by that.
That's one way to do it. Yeah, that's a good point. Just sort it by last block height as the default. I think that's a great. Yeah, that's the simple solution there. Yeah.
Yeah, they are not even close, so the order shouldn't be affected in real time. So yeah.
Okay. Great.
Okay, just to summarize, just sort the table by block height, fix the table responsive, make it sure the card names to be able to have a fixed size, remove the icons also to help on that, and the footnote, the footer note to the header, and the chain count includes Kusama, right?
Exactly. You got it all. Perfect. Okay. Okay. Anything else we need to discuss on the relayer front end?
No, not for my side, but I will create these changes. I will deploy them in the development environment. And after that, I will reset the testnet and update the testnet relayer front end with the latest changes.
Let's update the testnet relayer front end when we have pull request merged,
Yeah.
so
Yeah,
that we
but
always
in terms
have the
of
latest
order.
one there.
Yeah. Okay.
When you say reset the testnet, you mean setting up the testnet B instance?
Yeah.
Okay.
That's what I meant. Sorry.
Just be clear, we're not resetting the testnet that we have right now yet.
Yeah.
Okay. Okay, cool. Great. Thanks for going over all that, Leo. Looking good. Okay, so let's transition now into the last thing, which is going to be the kind of distributed storage API that Subspace is all about at the end of the day. The ability to put data on the network, get data from the network. So Nazar has recently gotten some changes pushed, which support sort of simple puts, so not anything complicated like feeds right now, which is, I think, too much mental load for developers to wrap their head around to start, but just literally just put some data into Subspace and get some data back out, like we talked about at the offsite. So Nazar's got that set up. So I'd like to spend a little bit of time going through that. Nazar, I don't think we need to go through like the entire sort of back end of how it works, just so much as what is the interface right now? What is the put interface in Substrate from like an extrinsic point of view? And what is the get interface from the RPC's point of view? And maybe just kind of explain at a high level what's actually occurring behind the scenes. And then Leo, we can move into a discussion of kind of Subspace JS and how we're going to build on top of this, what we're thinking.
So there is this new palette called Object Store. It's really simple, like 100 lines. The basic idea is that we have object store.put, which takes one argument data, and that data will be stored in extrinsic. It will be then mapped to objects when we want to retrieve it. So this is kind of like feeds, but without metadata, without feed ID, without nothing. It's like really, really simple. In the event, you'll get the author of who like submitted the data, object ID, which I think is something we need to add to the event of the Pallet Feeds eventually. This is like a hash of the data, but it can be anything, so it's really nice to expose it. This is what you will use to retrieve data later, and the object size kind of like in feeds we have. This is really, really simple. And there is another update on the farmer side, which goes hand in hand with this. We basically have an RPC server. Important thing to note about this is that there are two methods. One is getPiece, which takes a piece index as an argument. This is the building block for the future things that we'll use. For now, it's mostly not relevant. And there is a relevant thing, which is find object, which you provide one argument, which is object ID. That is the one that was returned from the event. And you'll get the object back. It might not exist, so that's why it's an option. And the object itself has a piece index, an offset within that piece where the data starts. And for convenience, the whole data is also available right away. So in the future, this will be gone. And you'll use this information plus the primitive get piece in order to reconstruct the data. And right now, there is a bunch of code that actually deals with that on the backend. But for simplicity, all Subspace.js will be doing initially, it will construct that RPC, it will construct that extrinsic to store data, and we'll use find object using that ID to retrieve it. So as long as you know the hash of the data, you can extract it from the network. That's the basic idea.
Thanks for the overview, Nazar. Do you guys have any questions about that? Does that make sense?
Yeah, I got a couple of questions. The get RPC endpoints are really clear, but I don't know if I missed the put RPC endpoint.
There is no
method.
Okay.
Yeah.
So on the put side, we'll be using object store. So this is kind of like pallet feeds, but it's a different palette. Latest node image has it. So instead of using feeds put, you will use object store put.
So it's a Subspace transaction.
Okay.
It's an extrinsic, basically. There's no RPC.
And
Actually,
it's just data as bytes, right?
yes.
Okay.
And actually, this object ID, it works already for feeds, but due to the fact that we are storing the whole block in feeds and the hash that everyone knows blocks by, it's actually a hash of the header. It's not the same hash. So if you know the object ID of the particular, let's say, Kusama block, you can also retrieve it.
Another question: can I test with the latest Docker images? This is already in the latest Docker images.
Yeah.
Or is okay. Nice.
Can go to apps. I can switch to my local. I'm not sure I have it. No, I probably don't have it. Yeah, probably not. Well, yeah, you'll just go to extrinsics and you'll see the another palette in here, object store.
Yeah, and having that there in there, actually, I can try with simple JavaScript in the JavaScript playground. So yeah, I think that I get. I think that I get it.
Great. So to summarize here, like to think in terms of other distributed storage APIs. So there's, one would be Arweave. One would be like BitTorrent, for example. What we're doing right now is not what our white paper describes, not what our long-term plan is, but to the developer, they really can't tell the difference because it's just an API. It's just an API where they put data in and get data out. So we're trying to expose that API to them soon so we can start actually working with partners and getting their feedback on this and understanding what the use cases are and building applications, right? So that's why this is deliberately simple on the put side, and that's why it's also simple on the get side, is that it kind of assumes every farmer is a full node, right? Which is kind of the way that Arweave works, where every miner stores the entire blockchain and has kind of the whole data set. So that's this is basically just like, I wouldn't even call it an MVP. This is like a proof of concept so that we can start getting feedback. It's kind of like almost an experiment to start getting feedback from users on. Now, fortunately, the external API should be very, very similar. It's still put, data, get object ID, return data, right? It's still, that's going to be the same. The difference is over the next few months, we're going to be upgrading this so that we have a more sophisticated Pallet object store, or maybe it's part of Pallet Feeds. This is a discussion Nazar and I have been having. We decided we're just going to table that for now. And on the get side, it's eventually going to query a distributed network. So instead of querying one node through get object, it's going to use this get piece, which Nazar showed, which we can kind of ignore for now, and it's going to query maybe a dozen or 100 different farmers on the network, get all the pieces, and then reconstruct the pieces into the object on the client side. That's going to come later. So we really don't need to worry about that right now. All we want to do right now is just wrap these calls in this very simple interface like we discussed at the offsite, and like Nazar already provided sort of this outline for what a high level API should look like, a TypeScript API, where we basically create a connection to the Subspace network. Right now, I think we do need an identity, yeah, but we could even abstract that if we wanted. But we put the data onto the network. We get an object ID back, which is basically just wrapping the data in a transaction, submitting this transaction to that call, to that object store dot put. And then and that's the put side. So there's kind of one workflow for the put side. Then there's another workflow for the get side, which is just create a WebSocket endpoint to a farmer on the network and retrieve the data from them. So really, whenever you're instantiating this Subspace JS client on the front end, you're going to basically create one connection to the network so that you can submit transactions. Like you're going to sort of join the Gossip network as a light client or subscribe to a provider, I guess. And then you're also going to connect to a farmer. And those are actually going to be two independent, network connections. Right now, it's an RPC connection to the farmer. Eventually, it will be something through like libp2p or some DHT kind of interface. But we can forget about that for now. Okay, so the next step is going to be creating this very simple Subspace JS interface. Like, we got to think like very, very sort of almost like a hacker, like very minimum viable product, like maybe even more of a proof of concept. And the point is just to get it so that it works. And then what we want to do is we want to start going to our partner. So I've already talked with Joe Petrowski at StateMine about this. We're going to work on on creating an NFT on StateMine that has some metadata associated, like a file, and storing the data on Subspace. And then like the next step would be to build like a really simple D app that shows this, like, oh, go create like a Subspace kitty or something like that. And then the data for the Subspace kitty is stored on Subspace. The actual code is stored on StateMine. You can create it and then you can fetch it, something like that as an example. Okay. Or as another example, it would be, well, we're storing all this wonderful data on Subspace. How do we get it out? Right? All these blocks. Okay, well, given a block hash, let's pull the block back out. And these are things that we just want to be able to give to people and to work with other people. Like there's literally people lined up to work with us. They're just like, when is this API going to be ready? When can we start interacting with you guys or interacting with your protocol? And so this is like this experimentation stage where we want to give them something, start getting their feedback, find out what kind of use cases they really care about, and probably we're going to throw this thing away and start over again, and maybe do that a couple times before we get to an interface that we're happy with. So I don't want us to spend too much time thinking about this, too much time trying to make this the perfect interface. I would just like it to be very simple and very easy to use. Those are sort of the two key criteria here. It doesn't have to be robust. It doesn't have to be, it doesn't have to be architected properly, because we're probably just going to throw it away and start over once we start getting feedback from people.
Yeah, I think that Nazar already sent me a template with the structure. I understand what we have to do. So, but just to resume, we need first to finish this storage or Subspace JS with this storage put, get, and find, right? And also an MVP front end to load and show the data in the network, right?
So the first priority is going to be the put and get, and then let's review that first and make sure we're happy with it. But then one of the next steps is going to be, there's a couple different potential like apps we can build to demo this out. But that is going to be the next step, and we're going to, like, you're going to build some of those apps for sure, Leo. But we're also going to give it to some other people and maybe have some like kind of like discovery calls with some other people to kind of get their feedback and see what they want to build with it.
I just started my local node with object store support, so I created a call, and this is how it looks like. And actually, the extrinsic itself is free for now, so we can make an API which will look like real API in terms of like we will have some kind of key pair, or we can integrate with the Polkadot.js extension, but it doesn't have to have any like tokens on it.
Yeah, so it's gonna be free. It's gonna be feeless for now, just for simplicity. We don't want that to be a blocker in this experience for new developers right now. Cool. Okay, and roughly, Leo, what I'm hoping is by the end of this week we can finish out the remaining tasks for the relayer front end, for the infrastructure side, and then by the end of next week, we can have like a version 1 of this Subspace JS that we can start looking at. And then following that, we can start playing around with some of these example apps and talking to some partners with this API. But I'm saying roughly 1 week is kind of like the maximum time frame we have to build this initial version. If you can do it better, if you can do it faster, that's even better.
I'll do my best. think that I got all noted, so I will
And for
send this
Subspace
to you.
JS, once we get to it, let's have a discussion separately.
Okay, cool. All right. Anything else we need to discuss regarding Storage API? Okay, great. Well, thanks a lot, everybody. Appreciate all the hard work on this. And thanks everybody for watching. We will see you guys next week.